sites, and you can see that in terms of the number of total deaths, cats by far are much more proficient at killing these native mammals than anything else is. Foxes killed 7, cats 25. You know, bear in mind that a cat is maybe only 2 kilos, a fox is probably several kilos, but cats are actually doing a very good job at killing those animals. And the ritchie, that's a native predator, the western quoll, only killed 1. So you can see cats having a big impact there. But there was one site where actually the mammals actually went against the trend, so that's tracking session through time, and this is the number of woylies, and you can see they've been increasing. So all sites, pretty much, mammals were going down, they were decreasing, but there was one site where bettongs were increasing in their numbers. And what's really important here is that we've got a graph here of cat density and fox density. And this is unbaited sites and baited sites. So basically what's going on here is that when you have really high foxes, you have low cats, you have low foxes, you have high cats. A fairly clear relationship there, basically showing that foxes are controlling cats. Now the interesting part about this story is the one place where those woylies, if you like, from before I showing where they're increasing, where they're actually found, was here. So where fox density is really high, native mammals don't do very well. Where cat numbers are really high, native mammals don't do very well either. Where they can potentially do well is in here, where you actually have a mixture of both. And the reason for that, we think, is that cats and foxes interfere with each other. So where you have both of them, cats and foxes are spending more time either trying to avoid each other or actually interact with each other, in the case of foxes killing cats. So they're spending less time hunting prey directly, but they're spending time actually affecting the predators, which gives the native prey species, in this case the small mammals, an advantage. And as shown in that picture there, we can obviously know that foxes themselves are very proficient hunters. So now quickly moving on to predators and biodiversity, and this is another native mammal from Australia called the coulter, which is the Aboriginal name. That's a small carnivorous marsupial. And here's another video, just because I'm sure you'd like to see pictures of Australian wildlife. This is a native poppy mouse. There you go. Now I just want to show you some of the quick general results we're finding. So this is an activity index. In this case, this is data from sand pads. So we go to areas and we sweep the sand. We make the sand nice and flat and clean. And then we come back the next day and we see how many tracks are on those sand patches, but also what species. So you can probably see here, hopefully, there's some footprints going down that sand pad. They're actually emu prints, so a very large bird. But you also get information on things like small mammals, reptiles, and even other small birds. But what you can see here is a pretty strong effect. So you can see for unbaited sites, that's where dingoes are present and generally quite abundant. You have much higher bird abundance, or activity if you like, sorry, reptiles, insects, and small mammals. And the converse is true where you don't have dingoes. The insect one was really interesting to me, and when I saw that one I thought, that's a bit weird. Why would you get more insects in the presence of dingoes? But then when I thought about it, I thought, well, actually that makes a lot of sense, because if you sort of think about trophic cascade theory and some of our results on plants, when you have more dingoes, you have more plant cover. What do insects eat a lot of? Generally, plants. So there's a really important effect here potentially that dingoes are increasing plant cover, which may actually influence insect abundance and availability, which is really important for these other species. Reptiles, birds, small mammals all eat insects in large numbers. So again, you can see that dingoes are really driving the system in an important way. This graph here is a bit more complicated. Hopefully I'll be able to talk you through it. This is just what's called a principal components analysis, which tries to describe the variation that's happening in the system, okay, all the variation. On this axis though, we have essentially more dingoes, if you like, more small and more native mammals. Going back this way, we have more kangaroos, more rabbits, more foxes and more cats. So in some ways, not what you want to have. That's more kind of herbivore grazing, more impacts of herbivores, more impacts of smaller predators. On this axis too, we have more kangaroos, and this one here we have more foxes, more cats, rabbits, etc. and small mammals. In this case, the small mammals are house mice, which are not the small mammals that people want in Australia. So house mice actually have a big effect in the landscape. Now each one of these dots means something a little bit different. So triangles are sites that have only been surveyed once in time. And then we have dots that are the same colour, and the asterisk means the point, if that site here has got an asterisk on it, that site was controlled, it was baited. So in this case, this site wasn't being controlled, and then at another point in time, this site was controlled, so dingoes were controlled. And what you can see then hopefully is that for sites where they went from a position of being controlled and then were then actually left alone, they moved more in this direction. Now bear in mind, this is the direction we want to go in terms of biodiversity. So you have more native mammals over here, you have less kangaroos, less cats, less foxes. In a situation where you have a place that was already being uncontrolled and then was being controlled, it went backwards in time. And you might think, well, those changes are actually very small. Now bear in mind, those are changes over 1 year. So these are really quick changes occurring. So what's really nice from this is it suggests that for sites where we can actually release the system in terms of letting dingoes back into the system, letting them have the controlling effects they have, systems can go from quite a negative state to moving to a more positive state quite quickly. So that is kind of some nice evidence there that having dingoes back in the landscape is a good idea. The question though, of course, is where do we go from here? The problems and the challenges for dingo conservation are no different to the problems and challenges for predator conservation, whether it be in Europe, whether it be in the US, wherever it is. They're all the same. There's big problems of how community, how people actually interact with predators. What we think about whether a species is native or not, because a dingo is controversial in that sense. Some people say we shouldn't have it at all because it's not even a native species. I would argue that that's beside the point. It's fulfilling a functional role that we don't otherwise have because we don't have any other native predators left. A survey was done in a newspaper in Australia, which is a fairly conservative newspaper for pastoralists. And I thought this would be really interesting to see what they think about dingoes, and I thought this probably won't go very well. This is some feedback that I got from someone, one of the farmers. I'm not sure if that translates very well here, but basically he was basically saying that I was pretty stupid. But what was interesting was that they had a survey there asking the farmers a very simple question. Should we bring dingoes, and in this case devils, Tasmanian devils, back into the landscape because of some of the positive effects they might have? Whoops. And what I found was amazing was that 89% of graziers were actually in favour of actually having predators back in the landscape. And this is really interesting because the media's perception, of course, is that graziers hate dingoes and they hate predators full stop. But actually, if you ask the graziers themselves, many of them actually want to have them back in the landscape because they know they can have actually quite important positive effects on controlling things like kangaroos, which they have to pay money generally to manage themselves. So the question therefore is, how do we go from a situation like this, which is the typical way of controlling pests, predators in Australia, lots of traps, lots of poison, to something like this, which many of you are probably familiar with. In this case, there's chickens in the background, but 2 Maremma guardian dogs actually protect those chickens from fox attack, rather than just going out there and poisoning and shooting foxes all the time. So how can we move from sort of that to more sustainable ways of managing wildlife? The other thing that's being entertained now too is reintroduction experiments. So this is Wilson's Promontory, which is in the southern part of Australia. It's a beautiful, pristine kind of landscape, if you like, which used to have Tasmanian devils up until about somewhere between 500 to 3,000 years ago. So really, that was almost like yesterday in an ecological sense. They should actually be there. We think that devils actually controls things like cats and foxes. So therefore, people are actually pushing the idea of putting devils back onto the mainland of Australia in areas to see if we can actually control invasive species naturally, rather than having to constantly use things like poisons and shooting, etc., to control their numbers. And the last one is, I guess, challenging bigger ideas in Australia. So some of you may or may not know there's a fence in Australia, and it's a very big fence. And when I say big fence, we have a fence in Australia that's a single fence that goes for 5,000 kilometres. It's the second biggest structure on Earth. So the Great Wall of China is actually longer. It's not continuous, but it's longer. But this is number 2. So the Dingo Barrier Fence goes for 5,000 kilometres, and it basically separates one half of Australia, the more productive part, where there's no dingoes inside there for sheep grazing. Outside of that, it's all cattle grazing. And huge amounts of money are spent on maintaining that fence, making sure dingoes don't get inside the fence, and all the other costs, of course, that also go with that, controlling kangaroo numbers in the absence of dingoes, etc. So you have to ask yourself the question, is there more elegant ways of actually managing wildlife rather than just building a 5,000 kilometre fence? And I'll leave it at that. Thank you very much.
Thanks, Euan. I think you can take your own questions for a few minutes if you want. Maybe we'll see what we get. A few minutes of questions, definitely time for that.
Yeah, more than happy to. Yeah.
If I can start, I'm not very familiar with the Australian natural history, but why got the marsupial lions and the Tasmanian tigers extinct on the mainland? Was it due to hunting by humans in historical way, or due to diseases? Or
Yeah, no, that's a really good question. In the case of the marsupial lion, it's actually thought that Aboriginals may actually cause extinction of them. So you might be aware that megafauna in different parts of the world disappeared in many parts of the world at different times, and many people implicated humans in that extinction. So in the case of marsupial lions, that was much, much more than 5,000 years ago, but Aboriginals arrived in Australia somewhere between 40 to 60,000 years ago. We're not entirely sure, but somewhere in that time period, and that's roughly the time that many of those other large animals disappeared. The Tasmanian tiger, though, is a different situation. So the thylacine disappeared around 3,000 years ago from the mainland, and that actually coincides really nicely with the arrival of the dingo. So this is a really interesting case point that the dingo itself may have actually caused the extinction of another top predator, but now that's all we're left with. So even if they did actually cause extinction of the thylacine, we actually still probably want to actually maintain dingoes on the mainland because they're actually controlling things like cats and foxes. So yeah, no, good question, thank you.
Yeah, thank you for your talk. I really liked it, and I have two questions.
Yep.
The first one would be like an example with the jaguar and bamboos. How do you make people understand that it's better to get the jaguar back that's gone for a reason than shooting the bamboos? There could be another solution, just controlling bamboos that way. And the other one is this holistic ecosystem approach. How do we transfer this your results to management? Like when we reintroduce predators to a system, when should we do that? Because I don't know if we can really foresee all the interactions. Should we reintroduce them to a small part and then see what's happening, or can we foresee or predict the interactions?
No, that's two really good questions. So answer your first one about the what do you do about leopards and lions in the case of baboons. It's really difficult. I guess something that's often missing, unfortunately, from ecology and conservation in general is more social research and more research on sort of trying to come up with ways to sort of incorporate other approaches to conservation. So in the case of leopards and lions, whether we can use things like guardian animals to protect humans' livestock, or whether you can fence off areas so that they can't come in and attack humans. Whether those kind of things are possible to do, you need to look at. But I think before you do any of that, really what we need to do is more research and actually asking humans what they think. And the humans that live in those areas, not what ecologists and academics think, but the people who actually live there think. And see whether that might actually inform what you do in a management sense. In terms of the reintroduction one, that's really tough as well. I completely agree with you that this is really complex, and then to just whack something back out there and hope that it goes okay is pretty risky. So what we're going to do in the case of the Tasmanian devils is reintroduce them to a small area within a fenced area, but still quite a large area, and kind of see what unfolds. And ideally, if the effects are largely positive, then you might then sort of increase the area that you release them over, but in a staged process. So you wouldn't just release them. But it's much harder to do for other parts of the world where there's really no obvious way to fence things off, or topography might make it really difficult to do that. So how do you let wolves come into a system and kind of control where they go? It's very difficult to do that. So yeah, it's a tough one. I don't think we've got the answers yet, but there are examples, I think, from parts of the world starting to come out now. Yellowstone National Park, of course, is a classic example. Sweden, we can see information there about what wolves and lynx are doing. And we're starting to see stuff in Australia about dingoes, but it's still quite early on to sort of generalise about what's going to happen when you introduce things back into systems where they used to be. Yeah.
We have time for one more, I think, if we've got one more. Otherwise, I had a really dumb last question.
There's no such thing as a dumb question yet.
Oh, I think there might be. As an old sort of Australian, aren't common wallaroos about the same size as eastern greys? So in your picture, you showed that the eastern greys were much bigger and therefore doing much better.
Yeah, they're close in body size. There's two differences there though with common wallaroos and eastern greys. Common wallaroo females are really small, so the dingoes can hunt them quite easily. The other thing about wallaroos is that up in rocky areas where they often live, they can avoid predators really easily, but they actually are quite happy to move out into flat areas as well, in open areas, but they'll only do that in the absence of dingoes. So they're actually poorer at avoiding predators than, say, eastern grey kangaroos, which are very fast, can escape dingoes very easily. So there is a big body size difference between female common wallaroos and males compared to eastern greys, female-male differences. So I think that's what's going on there. But yeah, it's an interesting thing that I've thought about as well, about why don't you see the same kind of pattern. But, yeah.
Thank you. So, if there aren't any more questions, last chance. Let's just thank Euan for what I think was a nice talk from another part of the world. Thank you.
Thank you.